Welcome to the YouTube channel on data science and finance. Today we are beginning Python. Let's try to understand the outline of this session. I believe it is important to know what is computer programming, apply your mind in solving problems through computer logic. And once we get an idea on the purpose of computer programming, we will look at how the code written by us is understood by the electronic machines. There are two approaches, compilers and interpreters. We'll have a short discussion about them, followed by understanding Python interpreter. Finally, we will end this session by downloading and installing Python on our local machine. Let's try to understand the purpose of computer programming. Assume that you want to pass some instructions to your computer. In order to do that, you need a purpose. What is the goal that you are achieving by passing an instruction to a computer? It may be perform an arbitrary task, like you might have used calculator to perform multiplication of three numbers or subtraction of four numbers. We could go beyond that to program to automate routine activities like paying monthly electricity bills. You can write an app or a small program to achieve this automation activity. Next, there are several complex computational problems waiting for us to be solved. One of them is an optimization problem. If you want to dispatch something, say from New York to Chicago, you want to find a right delivery service, how they are delivering it, and what is the cheapest price. You can solve this problem through optimization and programming. Next, in order to improve our efficiency, we have created a lot of software solutions, one of them being mobile banking. Compare the time before the internet era, wherein one has to go to bank to perform different banking activities. Whereas with mobile banking, if your mobile phone in your hands, you can do a lot of banking operations instead of going to banks. So in short, humans use computer programming to improve their day-to-day efficiencies, solve complex problems. Now that we got a bit of background on the purpose of computer programming, let's move on to understanding what are the different types of computer programming languages. Typically, we write code in high-level languages such as Python, C, C++, Java. High-level language logic written by developers and needs to be converted into a low-level language such as machine language so that the computers and their processors will understand and execute the logic written by humans in high level languages. For example, let's try to understand how an instruction is passed to CPU or a hardware. High level language, as mentioned earlier, allows humans to write the programs independent of particular type of a computer. For example, your hardware can be an Intel processor or AMD processor or NVIDIA. You are allowed to write programming in your high level language. Once that is done, high level language logic is converted into machine language. Low level language is typically represented through assembly language or machine language. The machine language is typically in binary format. The computer hardware understands the binary format. Any student who's into second grade and understands the arithmetic can follow this logic written in high level language, which implies that A and B are assigned to two numbers and then addition is stored in C. This high level logic is converted into the assembly language while translating high language code to machine language. The assembly language acts as an intermediary step so that you can understand whether this conversion is happening appropriately and logically as expected. Next, you have machine language. It is very difficult for anybody to understand machine language. This binary code is actually solving the arithmetic problem. We got a clarity on how an instruction from high level language convert to machine language. Now let us move on to the next part. There are two approaches to convert high level language to machine level language. One is compiler and other is interpreter. Both are nothing but software programs. Achieve same thing, but the approaches are different. Let's understand compiler. The compiler scans the whole program first and then converts code into machine code, a format called bytecode or an executable. This bytecode will be available for CPU to execute. Next, let's look at interpreter. The interpreter breaks down the entire code into small statements. Each statement is converted into machine code, and once a machine code is generated, it is executed by the CPU, and then it proceeds to the next statement within the entire code. An interpreter is required to be installed so that your code can be executed. Whereas in case of compiler, bytecode is available, you can move the bytecode instead of installing your compiler. Now let's understand how compilers operate. A majority of compilers follow a similar method in converting high-level language into machine-level language. The source code in high-level language is sent to the compiler. Then the compiler maps it into machine-level language through assembly language. In that process, if there are any errors encountered, then the compiler stops the compilation and displays an error to the developer. In case if there are no errors, then the compiler will generate the bytecode, and this bytecode or executable will be available for CPU to execute. I'm emphasizing the fact that the logic written is converted into bytecode. You no longer have to use compiler on your executable part. You just have to use the byte. Now let's understand with an illustration. Here you have a logic of swapping two numbers written in C and Java, as well as Fortran at the right side. What it does is you're temporarily saving the contents of vk in temp variable, and then contents of vk plus 1 are saved in vk, followed by saving the temp values in vk plus 1. So this is the logic of swaps. This logic of swaps is first converted into assembly language and then into machine language. This machine language is the executable. Now you may be wondering, why are both compilers creating same kind of machine language? Eventually, your CPU understands machine language in this format. Doesn't matter kind of compiler and programming language, the logic should consistently be converted into same kind of machine language. Only then CPU follows same instructions. So eventually what matters is your programming language can be anything. If your logic is same, the machine language should be consistent. Now let us move to interpreter. This logic of interpreter, where it converts high level language to machine level language, is consistent across different interpreters. In this case, the code is in Python commands. If you are writing large chunk of code, you typically save them in .py file. The current interpreter of Python has a version of 3.11.3. You can find the interpreter at a particular location. On my Mac, the version 3.111 is saved at this particular path. The entire code is broken down into a small statement, and that statement is passed to the interpreter to convert this high-level language statement into machine language. In case if the interpreter encounters any error, it stops the conversion and displays a message to the developer. Assume that there is no error in translating high-level code into machine level, then machine level code is generated for that particular block of statement. This machine level code is sent to CPU for execution. Interpreter goes to the next block of statement, and this process continues. Sequentially, converting the high level language into machine level language, it's important that interpreter should be available on your machine while running this Python program. I hope this is clear to you. Now let's move to download and install Python. You can use either of these two approaches. I highly recommend downloading from Python.org. Anaconda is a great tool. You can definitely download from anaconda.com. It comes with a suite of packages and makes your life a lot simpler. But I recommend you learning from the scratch by downloading from python.org/downloads. Once you download from this button, double click on the Python installer and let it finish the installation. After you download and install Python onto your computer, then it's important to understand where Python file is. Let me show how to do this whether you are on Mac or Windows. If you are Windows, go to command prompt and type Python 3. Otherwise, if you are in Mac, go to the terminal and type Python 3. It opens Python console. I'm going to show a small demo of how to identify where Python's interpreter is located. Type terminal and now type Python 3 on the terminal. It opens a Python console. So you could see install Python 3.11.3 directly from the Python downloads. Now I am putting sys an inbuilt package executable of Python. For that, I am typing this command. It shows that the Python 3 version is downloaded and is located at this path. Whenever I type, say, 8 plus 12, the sum will be 20. This 8 plus 12 operation would go to the Python interpreter, converts into machine code, and this machine level code will go to the CPU and it gives you the value of 20. That's how the Python interpreter operates. Thank you so much for your time and patience in listening to this session. Shall see you in the next session.